Hello. This is a video about the graphing sine, cosine, tangent, etc. So, in fact, on this one we will be tackling tangent. So, let's take a look. First of all, the work that you sent me was fantastic, and I also loved your explanation of that. What mathematicians usually say about the difference between sine and cosine is that sine and cosine, so let's see, cosine is sine scooted over to the left just pi over 2 radians. And you noted that you think that if they go on forever, that relationship will continue. Rory, Archie? And you're right, it does. It almost kind of looks like DNA when you put it together. It has this weird little helix-y thing that happens. Obviously, it's not three-dimensional. But regardless, every single wave function that you will see is some variant of sine or cosine. And before we jump into the amplitude and period stuff that I talked about, I do want to first tackle tangent. So that's the purpose of today's video, and you will need your unit circle and your work from Monday. So just like your work, mine looks very, very similar. And so here's the sine that we did together last time. And here is the cosine that I did without you because you did it on your own so beautifully. So to create our tangent is, if sine and cosine are like siblings, then tangent is like it's their cousin. It is very, very similar and definitely related to them, but did not grow up in the same household. So recall that on the unit circle, when we're looking at them, that x, y is the same as cosine of theta and sine of theta. Great. But also recall when we were creating tangent of theta, when we were looking at those with the special right triangles, with the unit circles, things like that, when we were doing all of that, we also noted that the tangent of theta was the same as sine over cosine. In other words, it's that y value over the x value. So this is what we're really going to be focusing in on for graphing the tangent. Now, before we actually compute what the y and x are, so that is what the tangent points are going to be on this wave function, let's actually just draw our plane. Instead of 20, I just want you to draw 10 up and down lines, then cut it in half, do 2 to the left, and again 24 to the right. And this is going to be our tangent. So at 24, that's going to be our 2 pi. Then you recall halfway through, 2, 4, 12 is going to be our pi. Then cut it in half again to do pi over 2 and 3 pi over 2. And then basically continue the exact same way that we had done with our sine and cosine. Our y values, as you see, are going to change, that we do need to go all the way up to 2 instead of 1, and down to -2 instead of -1. However, our x values do not change. So in the end, it should look like this. Bam. So now let's look to see exactly what each of these points is going to be. And this, like I said, we're going to do together. Let's start with 0 and pi and 2 pi. So at 0 on the unit circle, our y value is 0 and our x value is 1. So in that case, if we're doing the tangent of 0 degrees, that's going to be, again, y over x, so 0 over 1, which is just 0, and that's it. Well, that's easy. Then, let's see, then going to pi, that's going to become 0 over -1, so tan of pi equals 0 over -1. Well, it doesn't matter if it's negative, because it's still just going to be 0. I'll give you one guess what 2 pi is going to be. The exact same thing as 0. Great. Now let's look at pi over 2 and 3 pi over 2. So now this time, Our y is 1 and our x is 0. If you're thinking ahead, you should be a little concerned right now. So 1 over 0, because that's y over x. Uh-oh. Oh no! That doesn't exist. That doesn't make any sense. We cannot have a 1 over 0. So in other words, what it ends up creating is an infinite number of x values, that is angle measures, that are impossible. Therefore, they become asymptotes. So at pi over 2, I want you to draw an invisible line like that. And then there's pi. Pi was fine. What about 3 pi over 2? Oh, same thing. Negative 1 over 0. Negative 1 over 0 is still going to be impossible. That would just be negative 1 over 0. So at every pi over 2 and 3 pi over 2, it's going to end up looking like that. Now we just need to find out where it is everywhere else in between. Obviously, now that we have an infinite number of invisible lines that we cannot cross, this is not going to be a normal wave function at all. It is still going to be super valuable and useful in terms of the amount of things that we can do with it, but it is not a normal wave function. So let's see. Let's look at pi over 6. Pi over 6, that is this first point right here, is going to be, so first let's look at pi over 4, 3 pi over 4, 5 pi over 4, all of our pi over 4s. So that's going to be this right here. There's our x, there's our y, pi over 2, or sorry, rad 2 over 2 over rad 2 over 2. Well, what is something divided by itself? 1. So that means that that right there is just going to be 1. And then 3 pi over 4, there it is. Again, same thing, y over x. So rad 2 over 2 and then negative rad 2 over 2. Well, this time we're still going to have our 1, but now we've got a negative in there, so that is going to become negative 1 at 3 pi over 2. Then, sorry, at 3 pi over 4. Then 5 pi over 4, ooh, this time they're both negative. So a negative divided by a negative is a positive 1. And then finally, 7 pi over 4, this time the y value is negative. But since there's just one of them, that's going to, again, go back to negative 1. As you can see, we're definitely getting some sort of pattern here. We just don't know quite what it's going to look like yet. So let's look at our 6 and 3s. Let's see. Starting at pi over 6, we've got 1 over 2 and then rad 3 over 2. Well, let's actually write that out. So tan of pi over 6 is 1/2 over rad 3 over 2. Well, that's going to become 1/2 times 2 over rad 3 because of multiplying by the reciprocal, which is 1 over rad 3. Let's get rid of that radical in the denominator. So it becomes rad 3 over 3. So now, if we look up rad 3 over 3, that will give us 0.58. So that's about 0.5. So let's see. There is 0.5. I'm going to go a little bit above that to right there. Bam. Then let's do the same sort of thing to this. So now it's rad 3 over 2 over 1 over 2. Oh, well, that's almost the exact same sort of thing. Tan of pi over 3 equals rad 3 over 2 over 1 over 2. So that would become rad 3 over 1. Oh, this time we don't need to do that little trick because we don't have a radical in the denominator. So we can just do rad 3 all by itself, which gives us 1.73. So about 1 3/4. So there's 1, 1 1/2, 1 3/4. And I'm going to Yeah, right about there. And shabam. There we go. Now, I'm going to speed along real quick because let's just look to see what the rest of this will look like. So this next one is the same thing as that, but negative. So that's going to be negative 1 3/4. Then 5 pi over 6 is going to be negative 0.5, well, 0.58. So negative 0.58. So right by that. Then 7 pi over 6. So now this time all three of them are negative, which means they're all going to become positive again. So that will again become that, and that will again become that. And then finally, 5 pi over 3 is, again, one of them is negative and one is positive, so they'll be negative just like those two. So 5 pi over 3 will be down here, and 11 pi over 6 will be right there. So let's see what this mash of points ends up giving us. I'm actually going to start in the middle here. I think it's easiest to look at this chunk right here in between our two invisible asymptotes. So I'm going to start by sketching lightly because I think that's going to help us visualize what is going on here. Oh, well, look at that. It's going to go up forever, but because of this asymptote, as it gets closer and closer and closer, it's going to continue to curve up. So this right here is going to continue to curve up, and then as we go to the left, it's going to continue to curve down. Same thing here, and same thing to the right. That is what the tangent function looks like. So let's see what this would look like when we graph it using the calculator, just for fun, now that we've done this. For x, min, and max, let's actually say negative 2 pi for the min, and positive, 2 pi for the max. And then for the y, min, and max, I'm going to say, how about negative 3, positive 3. Then let's write in sine of x, and cosine of x, and tan of x, and see what happens when we graph all three of these. There's sine. Here comes cosine. And here comes tangent. You'll notice the calculator, to show us the invisible lines, it has to make them visible. But these straight up and down vertical lines, those are not actually part of the graph. It's just the whoop, whoop. Those are the parts that we're interested in. So that is sine, cosine, and tangent. In our next video, we're going to actually explore what these will look like and how we can fiddle with them in ways that are extremely similar to what we did with moving regular old functions around, just applying them to our favorite trig functions. Thanks so much. See you next time.